What's up everyone, Patrick here, and in this next question what we got to do is we got to find the value of m in each of these lines here. Notice we have 4 lines, and what we got to do is we got to find the value of m in each of these lines so that they're parallel to this line over here. 5x minus 4y plus 11 is equal to 0. Now, in order for 2 lines to be parallel, they have to have the same slope. And in order to check or to find out when lines have the same slope, you can compare different formats. You can compare 2 standard forms. So notice how this is in standard form. And then notice how these 2 lines here are in standard form. But you could also compare the y equals mx plus b form, the slope-intercept form. And notice that that form is over here in these 2 lines. So what I'm actually going to do first, this is already in standard form, I'm also going to take this line and convert it to slope-intercept form, just in case we need it. So what we would do is we would isolate for this y. So if we bring the negative 4y over, we'll have 5x plus 11 equals positive 4y, then divide everything by 4, and we would end up with y equals 5 over 4x plus 11 over 4, like that. All right, so this line and this line are the exact same thing. They're just in different formats. And so now we can go through. Notice this here, this line, it's in standard form as well. Not fully, this 3 should be on the other side, but when you're actually doing this kind of question, when you're checking for if lines or when lines have the same slope, you really just need the coefficients in front of the x and the y. So another way we could write this line here, if we were to put in this format, we could say 5x minus 4y equals negative 11, like that. But whether we have the 11 on this side or on that side, or the 3 on this side, that side, doesn't really matter as much for this question because we're really just looking at the coefficients in front of the x and the y. And what you want to do, if the lines are parallel, you want to make sure that the ratio of the coefficients is going to be the same. So basically, if we take this 5 and put it over 2, that ratio has to be the exact same as negative 4 over m, like that. In order for these 2 lines to be parallel, this ratio or this equation has to hold. Both of these ratios have to be the same. And so from there you could solve. And then we could have also did 2 over 5 equals m over negative 4. We would still get the same result. And so when we solve from here, we could cross multiply. 5m equals negative 8. M would be negative 8 over 5, like that. All right, so if this m value is negative 8 over 5, then both of these lines are going to be parallel. All right, and we did it by comparing both standard forms. Same thing for the second line. We got mx minus 6y minus 3 is equal to 0. So basically, we don't have to worry about the negative 3. What we could say is we could say m over 5 has to equal negative 6 over negative 4. Just make sure that these 2 numerators are coming from the same line. These 2 denominators are coming from the same line. Right? So notice the m, negative 6, then the 5, negative 4, like that. So from here, we got negative 4m equals negative 30. M equals negative 30 over 4, which would simplify to positive 15 over 2, like that. The negatives would cancel out. So for this line here at an m value of 15 over 2, this and this are going to be parallel. Another way you could do this, I'll just mention it here, is you could take this line. I personally don't like to do it this way, but you could also take this line and put it in this same format. So we can go bring the negative 6y over, divide both sides by 6, we would end up with m over 6x minus 3 over 6, which is 1 over 2. So this line and this line are the exact same thing. And in order for both of these lines to have, or to be parallel, they got to have the same slope. So we could say m over 6 equals 5 over 4. And notice when we cross multiply, when we do that same process, we would end up with 15 over 2 again. Right? But if it's already in standard form, you got this in standard form, personally I prefer to do it the ratio way. But then something like this, if we have this line in slope-intercept form, we could take this compared to this. We could also bring the y over, so we'd have mx minus y plus 2. You could put this in standard form and then do the ratios. Or we can just look at the slope. And notice in this case that m just has to be 5 over 4 here, right? They both have to have the same slope in order for them to be parallel. And then finally, number 4, notice we have y equals 5 over 4x plus m. Well, notice that in this case, we're already given the slope of the line, right? The slope of this line is not dependent on the m value, and it's 5 over 4, and then we have 5 over 4 over here. So notice that this m value, in this case, it could actually be anything, any real number, right? Or we could say m can be from negative infinity to positive infinity. It doesn't matter what m value is going to go here. It could be 0, it could be negative, it could be positive. No matter what m value you put here, it could even be 11 over 4. The lines would still be parallel, they would just be the same line then. So no matter what m value we put here, this line and this line will always be parallel because they already have the same slope.